Testing. Okay, I think there's sound now.
All right, cool. Are we starting again? Hello, everybody. Sorry for the technical difficulties. Welcome to another edition of the MakeCode Arcade Advanced stream. My name is Richard. I'm at Richard on the forum.
I'm Shannon at Shakao on the forum. Oh, Vivian, you're muted.
I'm Vivian at LoveTrip on the forum.
And I'm Daryl at Darzu on the forum, and technical issues master.
All right, cool. So we were already talking a little bit about the game we're going to make today, but since nobody heard it, Shannon, do you want to talk a little bit again about the theme for the game that you had, and I'll talk a little bit about what we're actually going to be making?
For sure, yeah. So the idea that I had was that we should make a game featuring like a combo mechanic. And combo can mean a lot of different things. So like in a fighting game, it's, a sequence of attacks that you execute. Or in like a rhythm game, it's, hitting all the right notes without missing any of them a lot of times in a row. And so it's a cool mechanic, and we've never used it in any of our games, so we wanted to make something that kind of featured that.
Yeah, and so when Shannon mentioned that, I thought of a game that I played a lot as a kid for the Game Boy Advance, which was Kirby's Nightmare in Dreamland. That was a remake of a game for the NES, I think. And in it had a mini game called Kirby's Air Grind, which is a fun little game. And basically the mechanics for that game were it was a one-button game, so all you had to do was press A. And Kirby would be following a line, which was a rail. The rail would go between spots that were bumpy and then spots that were smooth. And you had to lift the A button when you went over a bumpy part and then press the A button again when you got back to the smooth part of the rail. And depending on how quickly you did that between the transitions, you would get more of a speed boost and you could keep going. So the incentive to hold the A button down is that you only kind of accelerate while you're holding A. So you can't just, leave the A button up and then expect to win the game. So that was kind of my basic idea. I think we're going to make something like that, and we're going to make it a little bit more combo-y, because the original game had some combo system, like it would tell you nice or great, depending on how well you executed an action. But we want to make it so that those good hits kind of build up and make you faster and faster in the game, so you can get a better time. To start with, I've just opened up a new project here, but I'm going to immediately add an extension, because there's one extension that is very good for combo type things, which was the status bar extension made by Joey. So you've probably seen us use this on past streams before. There's also a post about it on the forum that kind of explains how to use it, but it's just a really nice extension for making bars with values that you can change and have it nicely animate between those different values. So I'm going to add this extension real quick. All right, cool. And I've gotten a new category called status bars. And I'll go over this real quick, but I'm just going to be making one big status bar. So that's the first thing I'm going to be doing. And it's going to go across the top of the screen. And it's going to be a combo bar. Every time you do an action well, the combo is going to go up. And then when you miss, it's going to go to 0. And it's also just going to steadily decrease. So it'll always be going down. So the goal is to keep the combo bar up so that you keep getting those extra speed boosts when you press the A button. So yeah, let's go ahead and create that bar real quick. So this looks a lot like our create sprite block, and there's a reason for that. This actually returns a sprite. It's a sprite that is also a status bar, but it means that all the blocks that we have in the sprites category that refer to sprites can also be used on these, which is how I'm going to set the position. So let me go ahead and drag out our set property block. I'm going to change this to status bar, change this to top, and I want to set the top to be like, I don't know, that's probably too much, probably like 2 pixels. Cool. So now it's 2 pixels away from the start, from the top. So this status bar is pretty short right now. So let's go ahead and make it a lot longer. The width of the screen is 160 pixels. So I'm gonna make this maybe like, I have 2 pixels of spacing, so maybe 156. Now the spacing on the side should be the same as the spacing up top. And I'm also gonna change the height, maybe twice as big. So let's make it 8. All right, cool. So now we've got this big bar up here. The other thing I wanna do real quick is give a label to this bar. And this might mess things up, so we'll see how the label works. I actually don't remember, but we're just gonna have it say combo. Yeah, cool. All right, I need to make it shorter because now I have this combo text that is pushing things over. So I'm just gonna put in some random values until I get something that works. Oh, I need to set the left also. Oh, whoops.
I think Joey said he was iterating on labels specifically. So.
Okay, cool. So it looks like I need maybe 4 more pixels. Maybe 8 more pixels. Cool. All right, awesome. So I've got a combo bowl and combo bar, and I'm also going to make it, I think, 1 pixel. I don't know, is that even on either side, or should I make it 1 pixel shorter?
No, that looks great.
I think it needs to be 1 pixel shorter. I think there's 2 pixels on here and then 1 pixel up top.
Yeah, it's a size 5.
There we go.
Font.
That looks better. All right. So right now this bar is full. I happen to know it's full just because I know that green means full when this dropdown is set to health. But let's show a little bit what it looks like when it's going down. So I'm going to go ahead and write the code to make that status bar go down right now. And I'm going to use an on-game update to do that. So let's go ahead and change this to on-game update every 100 milliseconds, just so it's executing pretty quickly. And I'm going to change the status bar value by -1. And now we should see it going down. And it also has this little animation that's chasing it. I'll probably turn that off. Just because it's more for like big hits to it. We might end up using it right now, but the idea behind that status bar is it's something you see a lot in turn-based RPGs where you lose health, and to show you exactly how much you lost, the bar will immediately go down, but you'll have like this little range kind of up top that shows you like this is the amount that attack did, and then it kind of follows after it. It's just a nice little effect. But it doesn't really apply in this case. So we're going to take this smooth transition and set it to off. So now it's just going down. These colors are pretty intense. So what's magic? Now it's a little too muted. Yeah, I like that.
Yeah.
Yellow's good.
Cool.
And you can also set your own colors too for the viewers.
Yes, of course, it has to be one of the 16 colors in Arcade, but we have this right here for setting the fill in the background, and you can also set a border. I'm not going to use a border right now, though. So. Cool. All right. So we've got our status bar, we've got our value changing, and I'll probably just leave this code because honestly, that looks like a pretty good rate for it to decrease at. So we'll maybe end up tweaking this 100 milliseconds later. But right now, I'm just going to put this over here. You might be wondering, what is the value that this starts at? And I believe it's 100. Not 100% sure about that, though. Do you guys happen to know? In any case, let's make it explicit. So I'm going to set the max too.
I believe it's 102, but actually now I'm doubting myself.
Okay, this looks good. All right, so I don't like having a lot of code like this in my on start, so I'm going to go ahead and put this in a function just to make the code a little more clear. And I'm going to call this create combo bar. And I'll go ahead and put this code in here. I'll put it next to my on-game update since these are related. And now I'm going to call that function. You see I'm getting an error right now because this code right here is referring to a variable that isn't being created. So when I call that function, I should stop getting that error and we should get back to the program like it was before. Cool. All right. So now we've kind of come to a decision point, which is what do we want our character to be? And also, how do we want to implement this? We could use tile maps. We could also just make kind of sprites appear on the right and then come to the left. What do you think?
Are we going to do a surfing game like Kirby or not?
I'm thinking surfing game in terms of mechanics, but it could be, you know, any sort of thing, you know. So what I was thinking for with tile maps was that we could like create a tile map and then probably create a bunch of tiles that look like this, basically. And like this would be a section of rail. And then we could also have some maybe that like turn. And it would be fun to figure out how to make that work. And then we could just design like a really long squiggly path for them to follow.
Sounds fun.
All right, let's do that. So I'm going to go ahead and create my little rail pieces right now. And I'm going to go ahead and set up a convention, which is that I want all of my rails to start in the middle. And the reason that I'm doing that is just to make it so I can do those turn pieces. But just so you know, all of the rails are going to start in the middle. And for the first one, let's just do a horizontal piece. So we do that. Now let's do the same thing, but we're going to do vertical. And you know what? I'm going to stop using this background so that we can have a background color. Hopefully this will be visible enough. You know what? I'm just going to make it a color that I know will be visible. And that'll be the color of our rail. It's going to be pink.
You could be like a mouse running along pipes, or
Yeah.
How does the blood system work? Are there things that go? Because I think it could be like veins or arteries. Maybe there's clots.
No, I'm very squeamish, so let's not do that.
Sorry.
You could be a sea turtle swimming through a current.
You could be a mail parcel going through a pneumatic tube.
Our team has a love of pneumatic tubes. I don't really know why, but all of us love them. And we like talking about them a lot. So pneumatic tubes sounds good to me. Oh, shoot. I edited that one instead of duplicate.
It's kind of up there with Zeppelins for me, of like technologies that we abandoned that, you know, it's a shame we abandoned.
I mean, Zeppelins were kind of problematic.
But they were so cool. They were just floating up there.
Yeah, then they catch on fire.
Only
if you use hydrogen. Helium was pretty safe.
Aren't they still a thing? Like they have those big advertising balloons.
Yeah.
There's a person in there, right?
There's like
can't
one
take an
person in
airship
there.
from London to Berlin anymore.
Like they used to be like
Twitter
cruise
talk.
ships.
Daryl.
Like they used to have, you know, I keep doing the same thing, which is I'm clicking the edit instead of the duplicate. So let me go ahead and do that. And I have that one, that one, that one, and I need one that's going to the bottom left. Sorry, yeah, so Zeppelins, they used to be like the Titanic. They had like huge, you know, dining rooms and things. It was really cool.
The chat says like in Indiana Jones. Is there a Zeppelin?
Yeah, and the third one.
Oh, okay.
Okay.
One of
So we've got
the
our
officers forgets a ticket. Anyway, sorry, keep going.
Oh, good. It was important information. Okay, so we have our good rail here, which is going to be this pink. And since this is a pneumatic tube, I think I'm actually going to make it blue. So let me go ahead and do that real quick. Now what I'm going to do is I'm going to go ahead and make some bad rail parts. And these are the ones that you're going to have to lift the button on. So to do that, I'm probably just going to do it for the vertical and horizontal one, just to make it a little easier to code. So the turn ones will always be safe. All right, cool. So let's go ahead and we're going to duplicate this one and duplicate this one. And what should our like broken rail look like? Maybe just like a different color, or
Vivian, you're muted.
I muted myself. Maybe there's like a hole in the tube and you gotta like plug it as you go so you can keep on going fast. Or a different color.
so something like that?
I think my issue is I don't really know how pneumatic tubes work, and I don't know where they get their speed from.
They get it from just like pneumatic pressure. So it's like pumping air, I think.
So if there was like a leak in it, it wouldn't be going fast anymore?
Yeah, I don't think so.
Okay. I was thinking like maybe there's a hole in it, and if you had like the cardboard thing as you were going and you were like, don't be a leak anymore, then you would keep on going fast.
Yeah. All right, cool. Let's go ahead and start real quick with just defining a map. So I need a start rail and I need an end rail. So I'm just going to do horizontal for that, and I'm going to make it pink like it was before. And I'll just know that that means start. So I'm going to put my start rail right here. And this might be a little hard to see because I probably should have made the rail thicker. But let's go ahead and just draw a whole zigzag. This one's going to be a hairpin turn. And then I'm going to put broken portion right there. This is not a very efficient pneumatic tube system.
I'm just imagining, this is routing through some old brick building, they retrofitted pneumatic tubes into, and they had to work around all these other rooms and stuff.
Mm-hmm. I did the same thing I always do, which is I accidentally made the start one out of the original tile. So there we go. All right. The place I always saw pneumatic tubes as a kid was at Albertsons, the grocery store. They had a bunch of pneumatic tubes that they used for sending money to the cash registers and back. And I always thought it was super cool.
Oh. Does the Seattle Library use tubes to send books around?
I don't think that would work, but they have a conveyor belt system, I think.
Oh, yeah. I think
right.
I have a very weak understanding of pneumatic tubes.
This is enough for now. So let's go ahead and start with this, and we'll do a little testing. So cool, we got our rail right here. And let's create our player. So for the pneumatic tube, it's probably just going to be, I don't want to deal with making the sprite kind of change depending on the direction it's going. So I'm probably just going to make it a circle. It should probably be a little less than 8 by 8. No, actually, that's fine. And we're going to...
I'm sort of imagining like cartoonish tubes where like a thing going through the tube like bulges out the side,
I have no idea what you're talking about.
Like in
like
cartoons,
a snake
like if
eating
something's
a
coming.
mouse.
Yeah,
Right?
kind of like that, except I guess less dark. Like I feel like there's this trope of like a cartoon or something that falls into like a drain pipe or something, and you can just see it like, just bulges the tube. I'll try and find a clip later.
Oh, whoops, wrong tile, not the block. So I want to place our player on top of the start tile. So I'm going to do that real quick. And we're going to just use the place on top of random, which of course has the fun property of always choosing the tile you want if you only have one of that tile. So this always put it on the pink because we know that there's only one pink tile on our tile map. The other thing I'm going to do real quick is rename this variable to the player, just because it's best not to use the mySprite variable. Otherwise, you'll end up making bugs in your program. So it's good to keep track of that. OK, so now we have to figure out what kind of tile we are on at a given point of time. And so to do that, we're going to need to track two things, I think, which is the direction that we're currently going. So we know if we're going kind of like which of the 4 cardinal directions. So I'm going to go ahead and make a little key right now just to track what each of those are. And I always go clockwise just because it makes it easier for me to remember. And to start with, we want to go to the right. So I'm going to set the direction to 1, because that's east. And now what I think we want to do is we're going to have an on-game update, which is going to, every frame, check to see what tile we are currently under. And we'll do the kind of positioning of the sprite based on that. So we're going to go into the scene category again, and we're going to grab this tile to center of the player is this. And this is just going to be a fun little giant switch statement. And I might put this in a function later, but let's just do this for now. Okay, so we have 6 different kinds of tiles, 8 if you count the ones that have like broken parts. So let's go into the first one, which will just be the horizontal. Then we'll do the vertical. Then we're going to do the 4 corners.
Mm.
2, 3, 4. And then we're going to do the, what's up, Daryl?
Aren't the corners ambiguous? Like, do you know which corner you came in from, or which side you came in from and are exiting to?
Yeah, I'm going to store that information, I think.
Okay.
So then the next one is going to be this one. And I'm going to add another case, which is going to be the that one. And let's go ahead and go into logic. And I'm going to put in an or. And you know what? Actually, I'm not going to do that. Instead, I'm just going to, at the beginning, so we place the player on top of a random pink thing. We don't need this anymore. So in order to make this logic a little easier, I'm just going to turn that into a blue tile. So let's go ahead and do this. I'm going to grab a for each. So this is going to get an array of all the locations. Again, we only have 1, but this is the easiest way to kind of access it. So I'm going to do a for each over an array of all those locations. And then I'm going to go into scene and set the tile at that location. So do this. We're going to change it to the blue one. And for location, we're going to drag out this value. So now, there we go. That's blue. Okay. So I think that the way that we're going to do this is I'm going to have a position, which is going to be the position of the sprite kind of on this whole little rail system. It's always going to be going up. And each tile is 16 pixels wide. So basically the unit is going to be 16 of whatever this kind of position is to the current tile. And I think that should work okay. Does that sound all right to you guys? I'm
not sure I follow entirely. I think as you build it, it'll become a little more clear.
Okay. So I'm going to create a variable, and it's going to be called entered from. By the way, it's totally possible I'm going to completely spend all of my time trying to figure out how to make this work. So you've all been warned.
Oh, you're renaming that. Yeah.
Yeah, all right. So we want this entered from, and this entered from is going to be a direction just like we had. So right now we're going from west to east because we want to start going to the right. So I'm going to set the entered from's initial value to be 3. Okay. So now that we have this enter-frommed variable, the idea is that we're going to constantly check the location of the player to see what it is. And then we should be able to position the player based on the direction that they entered from and how far the offset they are in the current tile. And this is going to get a little complicated, but hopefully it'll make a little bit more sense when I'm working on it. So the first thing we want to do is we want to align the sprite position to be like where we came from. So we have the entered from west, and right now we're on the like a horizontal rail. So what I'm going to do is I'm going to say I need to figure out what the offset is inside the current position. And so to do that, I'm going to, like I said, create a variable called position. And this is going to start halfway through the first tile, so it's going to start at 8.
So is that X or Y or both?
Both.
Or, I see.
Yeah, it'll all make sense soon. So we have this position, which is how far we are on the rail. And normally we would be storing an X and Y, but because this is a linear track, I'm basically just mapping it down to one position, which is how far we are on the track. And I'm going to be repositioning the sprite based on the tile it's currently in, where it entered from, and its offset. And to calculate that offset, what I'm going to do is make a new variable. And that offset is going to be the position integer divided by 16. Or actually, I want the modulo, don't I?
Right.
So we're going to use the remainder. So this divided by 16. And what I'm going to do right now is this is going to make our sprite go really fast, but I'm going to change the position by 1 on every update. Okay. So the next thing we need is the current tile location of the player. And to do that, what I'm going to do is I'm going to go into variables and create 2 new variables, which are going to be column and row. And I'm going to set those using the sprite's current position. So if I use the integer divide, which was what I brought out last time, so that's under the square root dropdown, I'm going to take the sprite's x and integer divided by 16. And this will tell me what, sorry, this should be column. This will tell me the column I'm in. And this will tell me the row I'm in if I change this to y. So we're basically converting between coordinate systems here. We have the x and y, which is the location in the world, but we want to know the tile we're on. So each tile is 16 by 16, so this will kind of snap that to the column and row that we're in. And now I think what we need to do is we're going to go ahead and kind of figure out what the position should be for each of these tiles, and then what the next column and row should be. And hopefully this will work out. I don't know how long this is going to take me, but we'll see. I'm kind of already back to this horse, so we're going to keep going. Okay, so we have two different directions we could have entered from here. It's either going to be the west or the east. So I'm going to go ahead and check that real quick. So we're going to do an equals here. We're going to do the entered from, and we're going to see if this is, where's my key? Is west. So we want to see if this is 3. Otherwise, it has to be east, so we can just leave it like that. And in this case, we can set the sprite's position to be this bit of math I'm about to do. So we want the column times 16 plus the offset for the x. I always grab divide. And for this one, it's going to be the row times 16 plus 8, because the y will always be the same while we're in this tile. Cool. So we've got our guy going right now, but he's not ever changing the tile. And so to do that, what we want to do is we're going to say that if the offset is equal to 16, that means we're going to the next one. So we can go ahead and figure out, based on the direction we entered from and what the current tile is, what our next location should be and what the next entered from direction is going to be. So let's go ahead and do that real quick. To do that, I'm actually going to stop setting these column and row like this, but for now, I'm just going to leave this as is. Let's go ahead and do the opposite direction real quick, which is just going to be the same, but it's going to be the column times 16 plus, I think it's going to be, let's see, 16 minus offset. Does that sound right? Or 15 minus offset? And just to check that real quick, I'll go ahead and set this to 1, and we should see it doing the same thing in the opposite direction. Yeah, cool. All right. Now we want to go ahead and do this, and we're going to go into the logic and say if, I'm not going to rewrite this expression a million times, so I'm just going to write a variable that says we're going to say if the offset equals 0, or actually, I think it's if it equals 15, then we want to change our current position, and we want to change our, let's see, what's the word? We want to change our entered from direction. So I'm going to set this to offset equals 15. And we're going to do that variable I just created. If next tile, then the entered from, because we're going from this, is actually just always going to be the same for this case. So we don't need to do this, right? Because if you're going west, yeah, it'll always be the same. All right, cool. But we need to change the column and row. So like I said before, I'm actually going to take these out. So instead of setting this to be the sprite position on each screen, that's going to be end up getting a little tricky. So I'm actually just going to set this for the initial position. And then we're going to change the column and row based on the direction we entered from and the current tile. So if we entered from the east and we're going to the next tile, then what we want to do is we want to change the column by 1 because we are going positive X direction and we're moving to the next tile. So let's go ahead and do that. And cool. So I moved to here and then I stopped. And the reason why is because we haven't done the positioning logic for these other directions yet. There's also surely a simpler way to be doing this, but this is just the first thing I thought of. Okay, now we're going to do something very similar for all of the other directions. So let's go ahead and do that real quick. So now we're doing vertical. Instead of east and west, we have north and south. So I'm going to change this first one to be south because I guess I set that convention. So that's going to be 2. And this one will be north. So if we're going south, that's the positive Y direction. And whereas before we were adding the offset to the X, now the X is going to be constant. So we're just going to be column times 16 plus 8. And the row is going to be equal to the row times 16 plus offset. And in here, because now we're moving in the Y direction, we want to change this to change row by 1. Oh, whoops. All right. Oh, it's upset about something. Yeah, I'm sure we'll figure it out. So now I'm going to do this same thing here, except like before, I'm going to do this little 15 minus business for the Y. And I'll go ahead and get rid of this. So X is column times 16 plus 8. Row is row times 16 plus 15 minus offset. And we want to change the row by -1. All right, cool. So let's go ahead and I think the way we're going to do this now is I'm just going to do them by the order we hit them. And that way we'll be able to make a little progress as I'm coding all of these if statements. So next we have this, which is the moving from the east to the south. So let's go ahead and duplicate this again. And that looks like, oh, hey. Whoops. We duplicated that case. All right. Let's go ahead and put this in here. And now we have 2 different directions we could have entered from. We could have entered from the east, so that would be from the west, so that would be 3. Or we've entered from the south. And this one's a little more complicated, right? The reason being is that now we have to kind of break depending on if we are less than or greater than 8. So I'm going to go ahead and do that real quick. We're going to say if entered from equals 3, so we're entering from the west, then offset. I always forget that those are alphabetized.
Me too.
O is kind of a weird letter too. I feel like I always expect it to be later in the alphabet than it is.
True. Okay. So if the offset is less than or equal to 8, then we want to, you know what? I'm recognizing right now that there is a way that I could simplify this code quite a lot. So there's 2 different ways that I kind of place sprites. I'm either placing it on this horizontal line or I'm placing it on the vertical line, right? So if I take this logic and I kind of put it into a function, I might make this code a lot, have a lot fewer blocks and be a lot clearer.
Could you just use change sprite X by or change sprite Y by 1?
That would be a lot more complicated because I would have to, it would be tough for me to calculate the position.
Okay, you should do your thing.
No, I guess you're right. That should always work. I'm trying to think if that'll ever drift, but let's try it real quick. So I'm just going to get rid of this position. And let's go ahead and try using the change, and we'll see if this works. So if we entered from the west and the offset is less than 8, then we want to change x by 1. Otherwise, we want to change y by 1. Oh, I still have the set position in here. I should probably take this out. Cool. So that worked. It went down here, and it went down. It got a little confused at the end because I haven't done this kind of next tile business yet. So let's go ahead and do that real quick. So if we entered from the west, our next tile is going to be changing row by 1. So that's actually right. But what we didn't change is the entered from direction. So to do that, we're going to say the entered from is going to be from the north. So we're going to set entered from to 0. Or did I get that backwards?
That sounds right.
You know what, I'm gonna just make this code a little clearer, I'm going to switch over to the thing that was suggested by Shannon. So let's go into the change. It'll be change y by, so if we entered from the south, then we want to change y by -1. Otherwise, we want to change y by 1. Cool. It did a weird skip there.
It looks like it skipped an entire tile.
Oh. Is it that the offset isn't being updated in time or something?
But next tile should only be true if the offset is equal to 15. And the offset is always changing, the position is always changing by 1. So this should be, I think, okay. But you know what? I'm just going to ignore this for now. And we'll fix it if I can. We'll try and see if it kind of reveals itself as I do the rest of this code. Okay, so if offset is less than 8, yeah, let's go ahead and duplicate this. And now we're going in the opposite direction. So all we need to do, I think, is flip these and reverse the numbers. And we'll go ahead and get rid of this. And we want to reverse the number here too, and change entered from to be, let's see, we're going north, we're going east. So we are entering from the, we're going west. So we're entering from the east, which is 1. All right.
The change row by 1 didn't get flipped.
Ooh, I see. Oh, okay. So my entered from is wrong. Did I possibly switch the meaning of entered from? Okay, so entered from equals 3. That means we are entering from the west. So let me go ahead and clear this code up a bit. Just like before. All right. And okay, so if tiled center is vertical, if entered from equals 2, we are setting entered from to be, so let's see, which of these cases should be executing when we hit this tile? The y should be increasing. So the entered from should be equal to 0. And for this case, which is I entered from the west, I am setting the entered from to be 0. Does anyone see what's going wrong here?
Where is the offset computed again? Is that at the very top every time?
Oh, I know what's happening. I think I figured it out. I think what's happening is this tile to center of is what's breaking me. Because what we're doing is we're figuring out the tile to the center of the player, but they haven't transitioned to the next tile yet when the next tile is equal to 15. So what I'm going to do to get around this is I'm actually going to instead do a trick that is kind of annoying, but is pretty useful, which is I'm going to create a sprite called test sprite. And this sprite is going to be transparent. It's not going to be of type player. I'm going to change it to test. And what I'm going to do is I'm going to set its position to be within the column and row, and then check the tile to center of the test sprite to see what the tile is. And I think that should fix it. So I'm going to change all of these, the players, to be test sprite real quick. First though, is that kind of clear? Does that make sense why that was causing a bug?
I think so, yeah.
Okay, cool. So we're going to change it to test sprite, and we're always going to set the test sprite's location in this game update. And I'm just going to drag out our set position, and we're going to do the test sprite position, and it's going to be the column times 16. And I think this needs to have something in it. So let me go ahead and just make this say like a 1 by 1 dot or a 2 by 2 dot just to make it even. And I'm going to leave it up for now, but we're going to make it invisible in a sec. So we're going to set the test sprite position to be the column times 16 plus 8. And this will put it in the center of our tile. We're going to do the same thing for row. And what did I do wrong here? Let's see, column times 16 divided by every time. Okay, well, now it's getting farther, but we can actually see what our column and row is supposed to be. So hopefully we can figure out what this bug is. So it seems like it's working correctly for this, but then as soon as it hits a vertical, that's where we're running into trouble. So we're changing y by -1 here, which means that this should probably be -1 and this should probably be 1. Cool. All right. Now we're in business. All right. So let me go ahead and go into scene, and we're going to do a camera follow just so that we can keep our eyes on the player. All right, let's do this one next. So I'm going to duplicate this business. Oh no, whoops, I don't want to duplicate that one. I want to duplicate the bendy one. And let's see, that is this one right here. So we have two directions we can enter from. The first one is the north, so that'll be 0. And if the offset is less than 8 and we're entering from the north, then we want to be changing the y by 1. Otherwise, we want to change the x by 1. And the transition is going to be going right. So we want to change the column by 1. And we're going to change the entered from to be east or west. So that should be 3. Cool.
Yeah.
All right. So we got that one. Now let's go ahead and do this one real quick. So if offset is less than 8, we want to be changing the, so right. I think the way to do this is always just flip it and then flip the signs. Or I already did flip the signs.
Yes.
And then we're going to change the
right.
row by -1. That's right. And we're entering from the south, which is 2. And cool. All right, so that one's done. Let's go ahead and do the next one, which is this one right here. So we're going to duplicate this real quick. Head on down to this one. And we have 2 directions we can enter from. We can either enter from the west or we can enter from the south. So if we're entering from the west, then if the offset is less than 8, we want to change the x by 1. Otherwise, we want to change the y by -1 because we're going up. And we're going to be changing the row because we're going up to be -1. And we're going to change entered from to be south, which will be 2. Cool. Now let's do it for the other one. So we're going to just do what we always do, which is duplicate this, get rid of the old one, and we will swap these and swap the signs. So 1 here, -1. Instead of changing row by -1, we're going left. So we're going to be changing column by -1. And we're changing entered from to be east, which would be 1. All right, cool. So let's see, we're almost done. We've got one more to do, which is this one right here. And then we're going to make these horizontal ones match them. And then we'll probably find some bugs that I did, but.
I feel like the unexpected combo was Richard doing this, and as he did each if case, he got faster at doing it.
Yeah, I don't know. Maybe we'll pick up this game again tomorrow. I don't know. It depends on what people want to do, but we'll decide. Okay, so we're entering from the south, which is 0, 1, 2. So if the offset is less than 8, we want to change the y to be going up, so that's negative. And we want to change the x to be going positive, so this will be 1. And we're going right, so we're going to be changing the column by 1. And we're going to change the entered from to be from the
west.
West. Yep. Swear, I always get caught up. And take this. We will pull this one out. Switch X and Y. And switch the signs. Wait. There we go. And now we're going down, so we're going to be changing row by +1, and we're entering from the north, so we're going to change entered from to be 0. All right, let's see how far we get. Oh, right, we're going to stop at the same part. So the positioning for these guys, these 2 cases, is actually going to be the same as the other ones. So I'm just going to get rid of these 2 cases, and we'll handle the combo stuff later. So I'm going to grab a logic OR. Go ahead and put this one in here, and then go up to where we did the vertical one. All right, now we'll do the same thing for this one. And just to make it faster, I'm just going to duplicate this. All right, let's see how far we get. All right, so that's the one we messed up on. So let's go here. We're entering from the east.
Ooh.
So entered from should be equal to...
The offset's backwards. because you're going that way.
So I should reverse these, or?
Yeah, if the offset is less than 8, you want to be moving Y. Wait.
No, I don't think so. I think this is actually good. I think probably this is what's messing up. So let's see, we're going this way. We want to change the rail by +1 and then change entered from to 0. No, that's right. Okay, so we're starting from the right and we're going left. So we're changing X by -1. Then when we're above 8, we want to be changing Y by +1 to go down.
No, because it's below 8, because you're approaching from the other side. Right?
No. Yes. So like that, right?
Yes, maybe.
Should we use the debugger?
Could it be from the other corner setting things wrong on the exit?
Oh, that's true. That could be it. So we were coming from a this corner right here. So let's go ahead and check what we did for that one. So we are entering from the south. So that's when 0, 1, 2. So that's this one right here. And we are changing row by -1. So that's wrong. It should be column by -1. And we're entering from the east. So hopefully that should fix it.
Ooh, this is mesmerizing.
It is kind of satisfying to just watch this go.
Oh
I feel
man.
like
Yay.
we could randomly
All
generate
right.
these.
Well, it took the entire time, but we got this little rail following thing going. And I don't know, we'll probably have a discussion about whether or not we want to pick this game back up, but I guess we've gotten the hard part out of the way.
You should set the little tracker to invisible, and then we'll be exact.
Yeah, all right. So let's go ahead and do that. So I'm going to go into the sprites and grab the sprite flag. And I'm going to set the flag on test sprite invisible to be true. So now we can't see our little dot friend.
This is awesome.
It'd be more fun if we got to the actual game part, but it is kind of fun to watch this guy just follow the squiggle around. All right, so let's go ahead and call it here for today. So I'm Richard, @Richard on the forum.
I'm Shannon, @Shakao on the forum.
I'm Vivian, @LiveCheerful on the forum.
And I'm Daryl, and I'm invisible, and I'm Darzu on the forum.
Just one quick reminder, go to arcade.makecode.com/gamejam to find out information about the game jam we have going on right now, and check out our forum. And yeah, thanks for watching.